Are you here for your appointment?
How is the Doppler effect used in the real world?
Here, have a seat.
What is this device?
So this is an ultrasound device I'll be placing by your neck so I can measure the Doppler or the velocity of your blood flow in your carotid artery. There it is.
This is our ending question. What is the benefit of using ultrasound imaging instead of other imaging techniques? Hello everyone, I am the low frequency waveform, which is indicated to be red.
And I am the high frequency waveform indicated as blue. And I'm here to talk to you guys about how the Doppler effect works using mathematical equations. So we can look at the frequency of a waveform by dividing the velocity of the waveform by its peak-to-peak distance. And we can then multiply this by another ratio to get our newfound frequency, which is produced by our Doppler effect. And the ratio is just v over v minus vs. So that's just the speed of sound divided by the speed of sound minus the speed of whatever you're looking at is moving.
These sound waves are coming from what we call a transducer. This transducer is connected to a power source that could emit and receive these waveforms. This transducer has a piezoelectric crystal at the tip. This piezoelectric crystal is what is acting like a speaker, but instead of being a speaker, the piezoelectric crystal could also receive the waveforms.
And the initial frequency that we get from our transducer is represented as f. And the newfound frequency that we want to look at in our images is the f prime value. So if the waveform, or if our particles are moving closer to our transducer, we will get a higher frequency because all of the waveforms will be compressed. While if the particles are moving in the opposite direction, we will get waveforms shown as red.
This is our last question. What are other imaging techniques that can measure the Doppler effect?